Last week I gave you a handout. That handout's going to be unbelievably useful. There were 7 graphs on there. Correct? Speed and time graphs. And then your distance and time graphs. Distance and time, distance and time, distance and time. So on a speed time graph, this means constant speed. Let's just say this is 35. You'll realize that every time I see this object at whatever time, it's still going 35 miles an hour. Now, this can get very confusing, Emily, because this exact same graph on a distance time graph means something completely different. This one means at rest. Mr. Bullens, I don't understand how 2 graphs that look exactly the same can mean 2 different things. It's all about this. This means the speed stays the same. This means the distance has not changed. Kids, if you haven't changed your distance, you're still standing in the same place. Correct? Now, on a speed time graph, this meant acceleration. Now again, if I threw a couple numbers in here, so let's just call it 10, 20, 30, 40, 50. I notice that every time that I look at this graph, this object is getting faster and faster as time goes by. That's called acceleration. On a distance time graph, though, this actually means constant speed. Constant speed. Okay? Not overly difficult. I think I can get that one. Now, there's an opposite of this, where the graph goes like this, and this one's called deceleration. That's easy to remember. I think I've got that one. Then we've got 2 more things that we can talk about on a distance time graph. If it curves, this is acceleration. And then if I have the comparison of 2 things, the steeper is faster. Now, I know that's a lot. I'm writing very messy because I'm not trying to write this out nice and neat, because you all have this on a piece of paper. Most of us have it in our notebooks. If you don't, we need to get a notebook or get it in there. Now, they're going to take all of this information and they're going to start changing things up a little bit on a Sophia. So I'm going to go and tell you this is a distance time graph. We'll do the time in minutes. They're going to give you a graph that has multiple movements in it, Ava. Like, this object does 3 things. Now, I have to go back to the graphs that I just drew or look at the ones that, are in our notebooks. And I know, because this is a distance time graph, that this part of the graph is constant speed. This part of the graph is at rest, and this part of the graph means constant speed. And they might ask you, how long was this object at rest? How long was this object at rest? And you have to look at the graph, Knox, and tell me, how long was this object at rest? So I can see that the object stopped, and it's at rest for this period here, but how long is that? Well, if I look down here, it stopped from 3 to 6, which is a total of 3 minutes, right? I can understand how they might ask me that type of question. on a distance time graph. Miles for minutes. How many miles did this object go before it stopped? Victoria. I see that it went 5 miles, and then it just stays at 5 miles for the next, what is that, 6 minutes, 5 minutes. Not terrible, right? I'm not too sure why we even have our Chromebooks open. You don't need them right now. So let's go through some other examples, because when we get done with this, we're going to be asked to create our own graphs. And you're going to have to label the misconceptions that somebody might have on the graph. And we'll do that on some of these other things as well. Here are the annotations, and let's go to this one. Yep. All right, now I see a graph. We talked about this last week. Before I do anything, before I even read the question, Colton, what's the most important thing that I'm supposed to do with every one of these graphs? He's like, I know it's something, I'm not too sure what it is. Mason, what is the most important thing to do? A second to think about it. Do what? Not the DST Knox. Is this a distance time graph or a speed time graph? Because wouldn't it make those movements mean completely different things? It would. Now that I know that this is a distance time graph, I think back to the distance time graph that I drew earlier. Is this one comparing two objects? No. Do you see any curved lines? Nope. So it's going to be this and this, which is constant speed and at rest, because these are all distance, time. And you should be able to, Ava. I honestly would draw those out. That'd be the first thing I would do on the test is a memory dump and draw all 7 graphs, just so I don't even have to worry about it anymore. All right? Now, a toy robot moved from a starting point and traveled in a straight line. Does this mean he's traveling in a straight line? Does this mean up a hill, then up a big hill, then a straight line? These are not hills and roads. And down. This is not downhill. A lot of people get that confused. That's probably the first big misconception. They think these are hills. Can you understand, Josie, how someone might think that that's going up some big hills and flat roads? I go up a little hill. I go up a huge hill. I get to the top of the mountain. I drive down. There's a flat road. Then I drive way down, and I'm back to where I started. I can see how someone would say that. However, I know that that's not the case, because I'm using these two things right here. What describes the motion of the object between 3 and 4 seconds? So if I get rid of all of this, no, go away. I just want to erase. Now, please erase, not going to erase, whatever. How can I erase? There we go. What describes the motion of the robot between 3 and 4? I see that flat line. What do you think it's doing, Knox? Well, if it's a flat line, it is at rest. How long was this robot at rest? Really hard to tell me the answer to that if you're staring at the back of the room. Colton. How long? Oh, okay. I see what happened. He said 12 seconds. This 12 is actually meters. So these are meters. It's going to be in between here because we're measuring in seconds. So how long was it at rest? It's at rest between 3 and 4 seconds. How long was it at rest? How many seconds? Okay, so let's take a look at this. I know that this object went 2 seconds and it went 4 meters. Yes? I know that because the 2 is right here. I know it took from here to here is 1 second. How far apart are those two? Jace, how long is it at rest? How long is it at rest? No. Kids, this is just between 3 and 4. That's only 1 second. That's only 1 second. This thing was only in motion for 8 seconds total. It was only in motion for 8 seconds in total. Looks like we might be digging a little bit deeper into this than I thought we were going to today. I'm not even going to try that one yet. All right, here's another object. What's the most important thing for me to do before I even read the question on here, Chloe? Okay, is it a distance time graph or a speed time graph? And this one is a distance. You might see the word position over here. Position and distance are the same thing. What's the position of the object? 1 meter, 2 meters, 3 meters. What's the distance it moved? That's fine. Okay? What describes the motion of the objects from 3 to 4? So I see that right here is 3 to 4. Thinking back on the 4 DSTs, it's not a curved line, so it's not acceleration. I don't have 2 lines, so I'm not comparing the motion of an object. I'm going to get those flat lines and that straight line. You only have 2 choices on the distance time graph. What is that object doing from 3 to 4 seconds? Look at your piece of paper that you all have. Okay, it's distance, time. It's either this one or this one that looks similar to that. It's only one of the 2. Who wants to give it a shot? Knox. It's what? Okay, so if you said that this is acceleration, you've got that confused with a speed time graph. Because of the speed, you can see as time goes by, the object gets faster. This is not accelerating. Remember, acceleration on a distance time is that curved line. Maybe we need to spend some more time doing those before we get into this, because it seems like we're not quite there yet. It looks like one of these 2 to me. Which one of those 2 does it look like, Macon? And the bottom one is what? You should have that on yours. This is constant speed. Constant speed. Go ahead and stop this one because I'm going to have to do another.